Hi, good afternoon. Welcome to the first section of the 2022 JRS Sustainability webinar series. My name is Charlotte Lee, and I'm from the SATU President's Forum International Secretariat. SATU launched the Joint Research Scheme, or the JRS, in 2012. It serves as a matching platform for like-minded scholars from different SATU member universities to connect and form research collaborations together. Very often, the collaborations started as a team of SATU member universities and then further extended to a broader network with a bigger team. It symbolizes joint efforts in achieving research excellence across cultures, the experience of which should be shared to a broader audience. That is why we introduced the JRS webinar series and invite JRS project investigators to share their experience and the latest progress of the projects. Today is the first section of this webinar series, and we have Dr. Zafar Manggala Pravina of University Putra, Malaysia, and Dr. Alexander Kunz of Academia Sinica Taiwan as speakers, and Dr. Fai Srinaida of National Cheng Kung University as the chair. The topic of today is microplastics in Asian freshwater environment. So without further ado, let me pass the floor to Dr. Srinaida. Dr. Srinaida, please.
Yeah, my presentation. Can you see that? Is that working? I hope it is. Okay, Pravina is nodding, so perfect. Hi, everyone. Yes, thank you, Charlotte, for introducing this webinar. Thank you very much. Today we will talk about microplastics, and we have over 120 registrations for the webinar. So thank you, everyone, and welcome for joining and for being here. We have the majority of us today are from Asia. So there, and the majority of attendants are students, but there are also members from the public. There are people from the government and companies. So thank you everyone for joining, and I hope you will enjoy the webinar. What you can expect today are, or let me just quickly talk you through. The first 5 minutes, I'm going to quickly talk to you some opening things, and then Alex will start talking about microplastics pollution in urban rivers. And Pravina will go on to talk about aquaculture, microplastics and aquaculture products. At the end, there will be a quick or a session for question and answers, and I really invite you to participate and save your questions and interact with us. SATU, so Charlotte already mentioned it. SATU was founded in 2003, and it's a program that combines different universities in Asia. And how did this, what's the context of our project group? So in 2021, we came together and 18 researchers, 18 academics from different universities in this context, and we decided to create a project on microplastics. I was the project leader, and we had several aspects that we investigated. The main idea was to create a world map with actual pollution data, so that because we have researchers from everywhere in the world, so we wanted to make use of most of the resources that we have available. But there were also several other groups, and that also split out from it. There's now a follow-up where we investigate microplastics in drinking water, but I don't want to spend too much talking about that. We brought you today two studies from two specific studies, so not this review, that we would like to talk to you in more detail. So I would like to invite Alex to give the first talk here, but I will quickly introduce Alex as well. So Dr. Alexander Kunz is the research fellow at the Research Center of Environmental Changes in Academia Sinica in Taiwan, and he studied geology at the University of Cologne in Germany. He got his PhD at the Leuphana University in Lüneburg, also in Germany, and in 2011 he came to Taiwan and was working as a postdoc as lab manager at the Department of Geoscience in the National Taiwan University. During his time here in Taiwan, he liked to visit beaches of the island where the enormous number of marine debris caught his attention. Especially the microplastic pollution was of great interest to him, and since 2015 he engaged more and more in research about microplastic pollution on Taiwan's environment. And at that time, he was actually one of the first researchers in Taiwan working on microplastic pollution. And his early research was focused on the marine environment and beaches, but later he also moved on to freshwater systems with a focus on urban rivers. So this is what we will hear today, and to study the origins and sources of microplastics. At the moment, he also has involved with the Greenpeace East Asia project, where he investigates microplastics in wild animal faces from a variety of species in Taiwan and Hong Kong. So with that, Alex, I hope, I will give the floor to you and shoot or go for it. Welcome.
Yes, thank you for the introduction and for inviting me.
Please.
Can you hear me? Everything is working?
It is.
Yeah, okay, good. So I'm sharing my screen. Can you see something? No, wait a second. Something to see? I can't see.
Not yet.
Sorry. Why it's not working this time? Or somebody else is sharing. Falk, did you?
I stopped sharing my screen. But you are right. I remember there was some yes. There is this, but I can't open it. I remember we had this to move on with this thing.
Can you, first of all, Dr. Kunz, can you find the button of share?
Yes. Yeah, I'm clicking on the share button.
I gave you the right to present. Sorry, it was, I think now
I think you have the right, yeah, it works now. We can see your presentation.
Okay, so first of all, thank you for inviting me and giving me the opportunity to talk about my research, which is about the microplastic pollution of urban rivers. And I want to present two studies from Taiwan, which we did recently. First of all, I would like to make a big thank you to all the project partners who have been involved, because it was a quite big research what we did. So that was mainly Professor Löwemark from the National Taiwan University and Graham Wong, who did a lot of work for the Thomsoil River or Thomsoil River. And then, Dr. Falk Schneider and Nixon Anthony from National Cheng Kung University, who were involved in the project in Taichung. First of all, I want to give a brief introduction to microplastic, and then I will talk about our study in the Thomsoil River, northern Taiwan, where we did a time series of microplastic pollution in rivers. And then the second study in the U River in central Taiwan, where we are looking at the influence of land use on microplastic pollution, but also the role of storm sewers and investigating the terrestrial sources of microplastic. So microplastic, or in general, plastic litter is classified according to size. So basically everything what is larger than 25 millimeter is called macroplastic. 25 millimeter is the size of a bottle cap, so that's actually quite good to remember. Everything bigger than a bottle cap is macroplastic. Then there's the intermediate range, 5 to 25 millimeter, that's mesoplastic. And then everything smaller than 5 millimeter is called microplastic, but there's a small distinction between large microplastic, that's all particles 1 to 5 millimeter, and microplastic, or the actual microplastic, is everything smaller than 1 millimeter in size. And in general, any kind of synthetic polymer that is smaller than 5 or 1 millimeter size is microplastic. And the most common microplastic types are fragments. So these are just small pieces from larger plastic items. Then we have expanded polymers like styrofoam or other foamed plastics. Then there are pellets, or sometimes also called nurdles. There are usually two types in the environment, the egg shape, which you see in the upper part of the picture, and the cylindrical. And these are plastic resin, which is used as raw material in plastic production. And pellets are also often referred as primary microplastic, because these are small plastic particles that are already made as microplastic. Then there are the foil or film types. These are all kinds of very thin, flexible plastic pieces that come usually from plastic bags or packing foil. Lastly, there are the fibers or synthetic fibers, which are usually originating from clothing or other kind of fabric. And the major sources of microplastic are the household. So basically everybody of us is producing microplastic, if you want or not. One of the big sources are fibers that come from washing the clothes. Then there are microbeads from cosmetics, which have been already banned in many countries. But then also trivial things like opening of plastic packing that can generate microplastic particles. A second quite big source, which is a little bit overlooked actually, is rubber from tire abrasion. And it's estimated that every year more than 2 million tons of rubber particles are released only in the US and the European Union. So globally, this is a much higher amount. And then, of course, the industry is a large producer of microplastic. For example, styrofoam that is used in fishery and aquaculture breaks down and produces a huge amounts of styrofoam pieces in the oceans. Then cutting, grinding of plastic in construction or kind of craft workshops. And then another source is the spill of industrial pellets. That's actually quite a big source because these industrial pellets, which I showed you before, are often handled very carelessly. And it's not uncommon that whole shipping containers with pellets fell into the ocean and releasing millions of pellets. And then lastly, of course, the degradation of large plastic into smaller plastic. And given the amount of microplastic we have in the environment already, this is more or less an endless source for more microplastic to come. And yeah, the cause of microplastic or why microplastic is so problematic can be actually broken down in just two main groups. Of course, there are much more finer things that can happen, but I'm just mentioning very briefly. One is that animals can eat the plastic particles and that will cause injury or even death. So probably you have heard about these cases where birds, seabirds or fish eat plastic particles, the stomach gets full and they can't eat normal food anymore. Another part of the problem is that microplastic or plastic in general can take up chemicals, organic and metal pollutants, or it can contain own chemicals like softeners or flame retardants. They can release that to the environment. Or if animals eat that, then these chemicals can go into the food chain and be accumulated in the food chain. And in the end, they will end up on our tables. We will come now to our first study, which was the Thomsoil River in northern Taiwan. And Taiwan, a small island nation in the East Asia. And the Thomsoil River is the third largest river system in Taiwan. It has a catchment area of more than 2,700 square kilometers. And about 7.2 million people live in the catchment area. This is about 1/3 of Taiwan's population. And the second study was in central Taiwan. That's the U River. It's the fourth largest river system in Taiwan, has a catchment area of just a little bit more than 2,000 square kilometers, and 2.5 million people live in the catchment area. So these two rivers are heavily influenced by human activities. And the first study we did was actually started at a time when there was not much research about microplastic in rivers. It slowly started to emerge that rivers are a major contributor to plastic pollution in the oceans, but rivers are also very important sources for fresh water, drinking water, but also the habitat for fish and all these things. And surprisingly, Thomsoil River was ranked as one of the 20 most polluting rivers in a study in 2017. But the problem with that study was that there was actually no real field data. So they used modeling and other kind of data, but not real data from the river itself. So that was also a reason to study this river, just to provide actual data. Now my presentation stopped. Why? Okay. So we studied the 4 main rivers in northern Taiwan. These are Dahan River, Geelong River, Thomsoil River, and Xindian River. And we did a sampling every 2 weeks over 3 months. We went always to the same locations, took the same samples, and we wanted to estimate the amount of microplastic in the river, to see some temporal trends, but also try to estimate how much microplastic the rivers are actually carrying. And during the study, we filtered more than 680,000 liters of river water, and we extracted 16,776 microplastic particles, and they're all in the range of 0.3 to 5 millimeter size. And on average, in these rivers, there are 24.6 particles per cubic meter of water. But the amounts are varying. I will talk about this a little bit later. For sampling, we used a manta net, which we attached to a boat or we lowered down from bridges. And on the right side, you can see a sample from the Thomsoil River. This is unprocessed, so it's basically just taken out, washed, and put in a Petri dish before any kind of treatment. And I think you can already spot all the microplastic pieces, all these colorful pieces. And we found in the river system, basically in every sample we took, every time, microplastic particles. So there was not one single sample without plastic particles, which actually means that there's a widespread pollution in the river. And the amounts, they can range quite widely from 2.5 particles per cubic meter up to like 83 particles per cubic meter. Sometimes there have been also much higher values depending on the situation in terms of precipitation or no precipitation. And one interesting finding was that there's a large variation within the river, but not within the replicate samples. So I just want to show you one example. So we took at each location 3 samples, and for each sample, the amount of microplastic particles is relatively similar. But you can see when you go across the river that the amount is changing. So there's a big difference depending on which position in the river you take your samples. Of course, when you start to average everything, then you're getting these large variations in the data. And based on that study, we were wondering where the microplastic comes from. Because interestingly, the rivers in Taiwan, they're very short. So the rivers in our study area, they are not longer than 100 kilometers. And the travel time for any kind of particle in the river is just a few days up to maximum 1 month. So there's no time for plastic to disintegrate during that time. We also could see an increased microplastic abundance with increased precipitation. And that led us to the conclusion that land-based sources are probably the reason why there's the microplastic in the river. And in Taiwan, it's actually quite common that so the cities have very dense storm sewer networks. On the right side, you can see a map of Taipei. All the purple lines are storm sewer, and they are all draining directly into the river. On the left side, you see a picture from one of these kind of outlets. So when there's a strong rainfall, then they open these gates and flush all the sewer water into the rivers. And on the lower picture, you can see that near these gutters, there's often some plastic rubbish or even already small particles, so they get washed into the sewers and then transported into the rivers. And we are thinking that these storm sewers are actually one of the major pathways for microplastic. So, and then the second study I want to present quickly is where we studied the River in central Taiwan. We are actually looking a little bit more into this storm sewer problem. So in that study we did last year, we had 3 sampling campaigns during July, October, December to cover the whole area, which is important in the Taichung city. And we filtered a little bit more than 1 million liters of water, and we extracted almost 13,300 microplastic particles. Interestingly, the particles here we found are a bit smaller than in Taipei. So most of the particles are less than 1 millimeter in size. The mean particle size is about 0.7 millimeters. And on average, we found in the rivers 12.6 particles per cubic meter. So the pollution level is a bit lower in Taichung than in Taipei.
Alex, this is a 15 minutes reminder.
Okay. Yeah, and this is the results. So you can see the map with all the sampling locations and the number of particles we found. And you can actually see already a very nice picture that in the mountain area, so the green areas is the forest area, which is in the mountains, there's very low population. There are very, very low abundances of microplastic. There are 0 or very, very few particles. On the other hand, in the city area, you have very high abundances of microplastic particles. And when the river is traveling from the mountain area entering the urban area, we can actually see an immediate increase in microplastic particles. It's not the transition, it's really like a sharp jump in the concentrations. And we also looked into the land use a bit more detail for 2 rivers. We mapped out the different areas and the different land use types and then calculated for each sampling location the sub-catchment areas to see if there is some correlations between different land use types and microplastic abundance. And we can actually see that there are very nice correlation between the amount of industrial areas and microplastic pollution in the river. The opposite, we can see that there's less forest area, there's also less microplastic. So that means that it shows actually nicely that in the areas that have very low population or no industry, there's no microplastic, and in the city areas with high population and lots of industry, there's a lot of microplastic. And again, we could observe that in the vicinity of large storm sewer outlets, so each of these diamonds you can see on the map along the river is a storm sewer outlet or a pipe or a bigger network. And that the moment these storm sewers appear along the riverside, we can see an increase of microplastic particles. And that leads us to the conclusion that it seems that these storm sewer systems which drain the untreated rainwater into the river are probably one of the major pathways for microplastic pollution in the rivers. And in the end, the rivers carry everything into the ocean. So yeah, for the conclusion, so as I said, the urban rivers in Taiwan are polluted with microplastic. We have evidence for the Thomsoil and U River in 2 different areas of Taiwan, and we can fairly assume that other rivers in urban areas are polluted too. There's a strong anthropogenic influence. So human activities are probably the main driver for microplastic generation in freshwater system. It's the riverine microplastic originates from land. We think that because the residence time of plastic in rivers is too short to degrade into microplastic, and we can clearly see that the onset of microplastic pollution happens in urban areas. At least that's for Taiwan. I don't know if the rivers are longer, it's probably a different story. And we think that storm sewers and untreated wastewater act as pathways, and they are the main way how the microplastic enters the rivers, and from there it goes into the oceans. Okay, so I'm finished, and thank you for your attention.
Thank you very much. That was brilliant. Perfect on time. So thank you very much. I think there are many questions, but I would prefer to have all the questions at the end and then just move on now with Pravina. All right, let me first set up or try to set you up here with the... Maybe Pravina, maybe you can try if you can share your screen and I'll introduce you at the same time.
All right.
So Dr. Savamangala Pravina is an associate professor in the Department of Environmental and Occupational Health at the Faculty of Medicine and Health Science at the University of Putra, Malaysia. After joining this department in 2012, her research has mainly focused on pollution monitoring and the risk to human health, where she was recognized internationally. She has also invented 2 patents and 1 industrial design on water filter, which specifically for emergency situation use. Most recently, her team has extended research on microplastics in the environment complementary to the existing international efforts to bridge microplastics pollution data gaps from developing countries in Southeast Asia. So with that, yeah, I think I can give the floor to you, and we're very excited to see what you will share with us. Thank you.
Thanks, Falk. All right, a very good evening to everyone. I'm Pravina from University Putra, Malaysia. So before I start, I would like to thank Falk and Satu for this opportunity. So in this talk, I'll be sharing on how microplastic in environment along with infrastructure like plastic usage in aquaculture can result in accumulation of microplastics in aquaculture products. And then there are also some findings from Malaysia. All right, this is the outline of this presentation. First, we will look at the aquaculture production, and then we will see what are the types of aquaculture systems. And then I'll be sharing few of studies as an example based on these aquaculture systems, and then findings from Malaysia. So as an introduction, global aquaculture production continues to grow faster than other major food production, expected to grow by 33%. And then it also demonstrated high potential for food production, exceeding 50% of total fish consumption globally. And another important point is that 92.5% of world aquaculture production growth is actually in Southeast Asia region, and Malaysia as the top 15 country in this production. So when we look at the growth of aquaculture production, it associated with these factors: technology improvement, species diversification, and best management practice. But at the same time, the growth of this production also has its challenges in terms of climate change impact, the water usage, and as well as environmental concern about the food safety. And recently, I think about microplastic in the harvested product. So in general, when we talk aquaculture system, it can be divided into 4 basic categories by European Commission 2015: the water flow, species type, intensity, and water type. But when we look at microplastic studies involving this aquaculture production, basically it's focused in understanding the water flow, either it's open aquaculture system, the semi-closed, or the closed one. So it will be better if we understand a bit of these characteristics, so that when there are findings about this aquaculture production, it will help us to understand better. In open aquaculture, the aquatic species farming is conducted in wide of environment. It can be in the middle of sea, river, lake, estuary, and so ever. And then we have this open net system. They place it, and aquatic species farming is conducted. As you can see, there is water exchange between the open net, the water, and between the aquatic species as well. But in semi-closed aquaculture system, what happened is the water, the natural water, is transferred to certain location with ponds. So this natural water is transferred into this pond, and the aquatic species farming is conducted. Even here, we can observe there is water exchange, but maybe a bit lesser than open aquaculture system. Now comes the closed one. In closed environment, it is conducted in indoor, normally indoor. We will set all the setting for this aquatic species farming. As you can see, the water exchange between the natural environment with these tanks are very much less compared to previous 2 aquaculture systems. And these are the global aquaculture products so far. Importantly, if you can see, freshwater fish is in the increasing trend in terms of its production. Now I'll be sharing some findings based on the type open, semi-closed, and closed aquaculture system. These are findings from open and semi-closed aquaculture system. If you can still recall, they uses the natural water for the aquatic species farming, and both of these studies summarize that there is similarities between microplastic occurs in their raw water. It can be rivers, sea, and etc., with the accumulation of microplastic in the aquatic animal in this data. So the similarity shows that the anthropogenic activities, as Alex explained just now, these are the contributing sources in the natural environment from their raw water source that lastly also influence the accumulation of microplastic to their product. This is also another interesting study in Canada for shellfish aquaculture industry. And here, this research has found out that the microplastics, occurrence of microplastics are higher in aquaculture site compared to non-aquaculture site. So the reasons are, first, the location of this shellfish aquaculture, which took place in the lowest beach slope. So the lowest beach slope is actually a location where most of the plastic waste accumulated in coastal areas. So the accumulation of this plastic waste has also led to a formation of microplastic, and lastly to the higher microplastic data or occurrence in aquaculture site compared to the non-one. The second is the degradation of their plastic products that they use in the aquaculture production system. So the breakdown of this plastic product also resulted the occurrence of microplastic in the aquaculture site compared to the non-aquaculture site. Here are the only two studies available so far for closed aquaculture system. One is from Central and Eastern Europe, and another one is from Pearl River, China. Both of these studies is actually conducted using closed aquaculture system sample, and they have used surface water transferred to pond in indoor environment. So even both of these study also showed that microplastics that already exist in their raw surface water that being transferred into pond has resulted in accumulation of microplastic in this pond, and this fish pond that been used in closed aquaculture system then tend to be as a sink for this microplastic from natural environment. The similar findings from Pearl River surface water, and when they analyze the samples, water samples in fish ponds. So here, those are the few selected studies that I would like to show how microplastic in environment can influence the quality of aquaculture product. So here we can see, if you can recall, in open and semi-closed aquaculture system, you can still see the water exchange. But in closed aquaculture system, is definitely very minimal water exchange. And now what happened is the microplastics that in the certain tanks or pond entirely avoidable to be escaped. They definitely be in that pond. Plus, closed aquaculture system also uses wide range of plastic usage compared to open and semi-closed. So that resulted the tendency microplastic to be formed in this kind of closed aquaculture system. However, from the studies, very limited studies only from China and Europe that I've shared previously, and even lacking in Southeast Asia region. So here I am sharing findings from Malaysia, from two farms, closed aquaculture farm. I've signed a document that I'm not going to reveal more information, so I'm just going to explain the characteristic of this farm. Farm A is a closed aquaculture system. They uses tap water, 100% tap water. But if you can see, these are all the plastic product being used, and most of these plastic products being floated in each tank. And they are quite old. You can even see the decolorization and breakdown. This is Farm B, more into business, and Farm B also uses tap water plus river water, depending which species are they going to work for few months in terms of production. In Farm B, they are also using a bioflag system that reduce the spread of pathogen. It conserves feed input, which can lead to higher productivity. This is a business base, so definitely profit-minded farm. Okay, so these are all the samples that we collected, 2 species from Farm A and 3 from Farm B. They did not allow us to take any water sample, so there's only fish sample allowed, so we only took whatever they gave us based on species. And then mussel liver. gills and gastrointestinal tract were separated, and all these body parts were analyzed in terms of microplastics using density separation method. And then we also utilized two identification way to identify and reconfirm the presence of plastic polymer. So these are the microplastic particle found in few of the body parts. These are selected images. You can see in farm A, mostly in red color and the blue color. In farm B, they are mostly transparent, much more smaller compared to farm A. So these are the overall data. Microplastic were found in all the species from farm A and farm B, higher in farm A. And then we also found that the microplastics were higher in gastrointestinal tract of body parts for each species. It can be due to the feeding behavior and feeding habits of each fish species as well. Now, moving on, the reason that we could find to the higher number of microplastic particle in farm A compared to farm B is due to the abrasive forces between the water movement and the plastic products, which was higher in farm A, and these plastic products tends to be floating all the way during the operation process compared to farm B. There are very less plastic product floating on top the tanks. But here you can see in farm A the abbreviation, mechanical abbreviation between these plastic product. So in terms of this is microplastic shapes, you can see in farm A we have fiber as the main microplastic particle shape in farm A and fragments in farm B. In terms of color, blue and red dominated the most in farm A, transparent and brown in farm B. So we would like to see using all this data, the sources of these plastic microplastic particles. So here, the microplastic particle fiber in blue and red can be associated with the fishing net. You see the fishing nets in a blue color, and the lining of the fishing net has contributed to microplastic particle fiber in red and blue. And if you can see the bucket, you can see a very old bucket with red color, already lost the color, which is mostly in pink color, and as well as the transparent plastic tubes that contributed to the fragment microplastic particle. In farm B, the mechanical abbreviation is lesser, but the transparent microplastic can be associated with the plastic tubes, the old plastic tubes, and there are some breakdown that we observed during sampling. And the brown one is through this plastic net usage that is used to collect the sample from each tank. So the polymer identification has reconfirmed, yes, the microplastic particle found in these fish body parts can be associated directly with the plastic product used in aquaculture production system. So again, the occurrence of microplastics in the fish sample definitely poses a concern about its safety, about the production. At the same time, you can see the sources of microplastic in aquaculture production besides from the raw water. Even the plastic usage during the aquaculture production, especially in closed aquaculture system, is also one of the main points that needs further investigation. So this data is mainly in terms of microplastic accumulation. There are still one part which is still unclear till now, is the actual reach of this microplastic particle to health. In that part, I think we need to improve our methodology, the way of identification, so that this knowledge gap can be identified and answered soon. I think with that, thank you so much.
Brilliant. Thank you very much. That was very, very good. In this case, I would like to start the round of questions and answers. And actually, I have one question that maybe can be answered by both of you. So I'll start with that. Can you compare your study results with other regions? So for example, in your case, Pravina, are then the closed systems more polluted compared to previous closed loop systems? Or Alex, Taipei, the Thomsoil River has been identified or named one of the top 20 most polluting rivers in the world. Can you confirm that? Was it really dirty? Like, whoever wants to go first. Maybe Pravina, maybe you can go first.
Me, Fak?
Yeah.
I in my opinion, I think to compare is a difficult thing for microplastic data. The main point here is the methodology part that we have selected. Some are using density separation, some are using nets and so ever. So it's not only our problem. I think globally the comparison of microplastic data from one location to another is still a challenge in my point of view. Yeah.
And in our case for the river, it's a bit quite difficult because what we noticed is that so the microplastic is not homogeneously distributed in the water. So you have areas with higher concentrations and areas with lower concentrations. If you remember my slide, which I showed, you can see that depending on which side of the river, we get totally different numbers. So that's why we actually have the problem to extrapolate our results, because we have no clue if our results more or less realistic, underestimated, overestimated. We also sampled only the surface. We don't know how much is actually in the water itself. So I think the biggest challenge for us with the river studies is always to roughly know, is this probably underestimated what we have. It's probably more. But I also find it a bit, not really correct to extrapolate now the numbers, because it will give kind of unreasonable numbers. So globally, we cannot say if it's really that much polluted or not. I mean, it's kind of, I would say, from my experience, Thomsoil River, it's more like average polluted, not sure if it's really top 20.
Thank you. Let's see. Are there questions from the audience? I don't want to ask only my questions. So someone, please go if you have a question. If you have a question, there are two options. Raise your hand and you can be then unmuted. I think you can even unmute yourself. I'm not quite sure. Or the other option would be to write it in the chat. So yeah. Any questions from the audience? Otherwise, I'll keep going. All right, let's keep going. Alex, you mentioned that the top sources are not really. You said that in general, major sources of microplastics are rubberware industry, and I think you mentioned 4 different types of microplastic sources. And my question is, did you also did that match what you found in your studies, or did you see a completely different picture, maybe a 5th type or source?
Yeah, actually, we cannot really tell from the particle itself where it comes from. I mean, the only really characteristic particles are the pellets, but everything else is just a fragment or a fiber, and we have no clue if it comes from a household, if it comes from a washing machine, if it comes from a factory. That's unfortunate that we cannot really say. We didn't find rubber, but that could be due to our method, how we sample. Maybe that's kind of slips through. But in general, it's very hard to say what is, because in the river we see everything what came, so we need to go further out from the river and try to trace back something. But in our study, we didn't do that.
Okay, and Pravina, this is a little bit going further. So you said that you'd identified a lot of equipment pollution, like from the bucket or from like the different types of, let's say equipment, that were plastic equipment, that this was probably the cause of pollution in your products. Do you see anyone else in the literature, anyone else who has previously identified like cross-contamination from the equipment? Because you talked about like the natural environment was that the water itself was already polluted, but not necessarily that like the equipment in open water bodies also is also a contributor. Have you seen that other people talk about this equipment pollution as well? Or was it mainly you?
because there's only 2 studies available from closed aquaculture, and it happened to be both of these studies uses raw surface water as their water supply. But in my case is the tap water. So when we of course we are not given permission to take the tap water to analyze, but their piping system is made of by the galvanized iron, the old iron, so the old plastic pipe material. So there's a tendency, I don't think the microplastic can come from the tap water when it is supplied to the pond. But the similarity, because in the previous study, since the raw water is from the surface water, so I think they had a similar problem like Alex, to really know from where the microplastics real sources. But in my case, because they are using tap water, and the farm B, the tanks that we collected our sample also uses tap water, so it was easier for us to relate the plastic product. So the only literature available, if I'm not mistaken, one of the report from Denmark, if I really sure about it, then they also relate with plastic product. I think many aquaculture producers or managers need to know this. You can't use plastic products for quite some time. When you see there are breakdown of these or decolorization of plastic product, it is a time for you to change. But how many of them will do that? This is a business profit-minded sector. So that's why I think the previous studies unable to connect the real sources of microplastic particle.
I see that Alex raised the hand. So Alex.
Yes, there's one thing I want to add to your previous question about the sources. Actually, there's one type we cannot find in the river, which is very rare, and that's styrofoam. And both studies, the styrofoam content was really low. But when we look at ocean water or beaches, the styrofoam content is really high. And that's because styrofoam comes mostly from fishing industry, from all the styrofoam boxes, what they use, or from buoys, from ships. But we don't have that in the river. So that's why there's much less styrofoam, almost no styrofoam in rivers.
I'm just checking. Actually, there are questions here in the chat. I just wasn't aware, or let me just double check here. So there's a question. Oh no, that's the question how to sign up to the talk. Maybe let me go down here.
We have 2 questions.
All right.
Okay.
Do you want to help me, Charlotte, to ask those?
It's for Dr. Pravina. Then the audience says he or she realized that most of the microplastic pollution in a closed system aquaculture comes from the 2 used in that place. So is there any way to avoid or minimize that?
Yes, I think the next important thing when we have better data available is there should be certain guideline for these aquaculture producers in using plastic product. However, it is too early to say this, because the next question that they will ask is, what is the risk of this microplastic particle to human? I don't think so I have the answer now. So when I say no, then they will definitely deny, it's not necessary for me to control the usage of plastic product. But looking at other available literature, the how to avoid or minimize that is entirely depend on that aquaculture manager to control the usage of plastic product, number one, especially the old plastic products. From my presentation, you can notice most of the plastic products were very old. You can see the breakdown from during our sampling. So that's one way to minimize that. I think to entirely avoid is very difficult in aquaculture sector, but to control and minimize it, it's always a way to do that. It entirely depending on a better way of aquaculture management, and definitely comes with a clear guideline. Yeah.
Charlotte, do you want to go for the second
Thank
question?
you. Okay, yes. And so the audience would like to know whether you have considered airborne microplastics as well.
In this both closed aquaculture system, no, we didn't consider airborne microplastic. In fact, they didn't allow us to go and take photos the entire aquaculture farm. They only allow us to certain locations, so that's why my photos are very limited. But I know there are many photos that I can take during the sampling. So in that case, that's why we also couldn't take the tank water sample to be analyzed. If we have that data, that will be a perfect data to correlate the accumulation, but they didn't allow us. So no, we didn't consider that, Nur Irnawati.
Then another question is regarding the recommendations that result to it. And I would like maybe both of your opinions. Marina, you already mentioned a little bit that you need to maybe have a better control. But Alex, maybe in your case as well, what could happen? So maybe if you want to elaborate more, Pravina, but let's start with Alex.
Right. Mhm.
So what is your question?
What follows from this? So you said that you identified microplastics in rivers. So what is are there some recommendations you can give to policy? Are there some recommendations you can give to the house? Yeah.
Well, in our case, I mean, we are thinking that it comes from the storm sewers and that they're basically flushing everything what's on the street, on the ground, into the river. And I think that all this kind of water should go to a wastewater treatment plant. I mean, it's not only microplastic what goes into the rivers, it's anything else what's on the streets. So I think that's quite important. Also, we can see, at least here in Taiwan and Taiwanese cities, that there are lots of like small pipes coming out of houses going into the river, kind of still house sewage, raw sewage going in. I mean, it's not much, but there's still something happening. So I think in that case, there should also be more stricter regulations that no sewage water should go into the environment. I think that's the biggest thing we can do for the rivers.
Maybe I can add one point there because I was also present during the sampling in the Taichung River, and we had some areas where the storm sewer entered the river and there was like a death scene. So there were a lot of fish floating on top of the river. They were dead. So it was really, you could see that the color changed significantly after the storm sewer entered the river itself. So we really saw the impact the storm sewers had in this case, and that unfiltered water needs to be treated first. So I can fully support that. Pravina, do you want to add anything regarding recommendations on that point, or what would you hope maybe must happen? And yes, so not just to solve this issue.
My hope, I think it depends if we have enough awareness. Like today we know there are certain sources related to microplastic, especially from household. There are many ways you can change your behavior to minimize the discharge. The laundry water, that's another silent killer of microplastics. That's, it's been silent, but we know the laundry water is contributing certain important plastic polymer in terms of fibers. But how many of us know that? So for me, it's a behavior change, to change something to minimize this pollution. Yeah.
All right, now we have more specific questions. Charlotte, would you like to help me again?
Okay, we're stuck by Jessica. So as I think this is for Dr. Pravina.
Yes,
So
yes.
because of the tool of the agriculture is the source of the plastic. So would there be a better system more suitable for it to be changed immediately, or would it just depends on how the countries have more regulations and protocols?
Yeah, I think
Better control.
Yes, I think Jessica, that will be the second one. It's entirely depends on the countries, their rules and regulation in terms of aquaculture management. from what I know, there are certain pollutants being analyzed for aquaculture products in Malaysia. But in many countries, including Malaysia, I don't think so microplastic has been included as one of the pollutant in regulation. So it's entirely depends to the country. Yeah. And we have another question.
So I'll read it so everyone can hear it.
Oh, yes.
So have you been to any high-end closed aquaculture system with a very advanced water filter system or system like that, and had sampling there? And if yes, so what is the result?
I'm so sorry. I haven't been to very high-end closed aquaculture system. The one that I went was Farm B. I was impressed with that, but I don't think so. That was the best high-end closed aquaculture system. No, I'm sorry. I have no answer for this because I have never been to any high-end. But I believe developed country should have better high-end closed aquaculture system.
And it seems there's a question for Alex here. I'm just going to check here. I'm curious whether all suspected microplastics identified by Fourier transform. Now change the chat moves. Spectroscopy so FDIR for the polymer. So did you check all polymer materials? So, and I don't know what happened. The chat is moving up, so it's hard to keep track of the question. But maybe you can start there, Alex.
Yes, we checked them with FTIR and Raman spectroscopy, and the vast majority is polyethylene and polypropylene, so basically the two most common plastic types. Other minor types are like ABS plastic or PVC, but PE and PP are the most. Basically, like 80% of the plastic particles are only these two types.
And the question, thank you. And the question for Parina would be, how long were the sample fish cultured? And would there be more microplastics if you have a longer cultivation time? So, yeah.
Okay, so the fish sample that we received during the sampling is they call adult sample. The samples are ready for human consumption and etc. But what would the what we believe is the adult fish will have higher microplastic because you have longer time being cultured in that tanks compared to small one. And it also depend, I'm not a fish expert, but I have another collaborator who explained to me it also depends on the feeding habits and behavior of each species. They have their own characteristic of ingestion of the microplastic itself. So yes, culture time do influence the microplastic accumulation. And for our sample was the adult sample that they gave us for the further analysis.
Another question would be, but yeah, it's the question is, why is there so limited research or limited studies on microplastics in aquaculture in Malaysia? So it's a it's a question probably that you can answer too.
I think there's a connectivity between this topic is just a recent topic in it's dangerous to say Southeast Asian region, but it's a new topic for Malaysia. It's just they just started to notice, oh, okay, right, developed country has this kind of data, and there are high chances such sources also present in Malaysia. So yes, I think this topic has been started to be analyzed starting in 2007, if I'm not mistaken, starting from aquatic environment, beach environment, if I'm not mistaken. So I think awareness and etc. is needed, and that's why it leads to very limited study on microplastics.
Yeah. Maybe then a final question from the chat room. So because we're getting into the time, there's a question about cleaning up the water body, cleaning or removing microplastics. I think they say here solutions such as cleaning technology, if they exist, and what would be their application and possible use. both of you feel free to comment.
I mean, for water, there are attempts of, I think, using bacteria, also kind of filter system in wastewater treatment plants. But from what I know, nothing is really ready for large-scale applications. So everything is still in kind of experimental stage.
Pramina, do you want to add anything?
Yes, I think Alex was right, because they do have, say, like laundry water, they do have some cleaning technology to remove fibers. But are the technology working 100%? No, there are still limitation and improvement needed to improve this cleaning technology. Yeah.
And I think I can add that, yeah, wastewater treatment plants itself, the cleaning process can actually add to the microplastic pollution. So it's not necessarily the golden bullet that will solve all our issues. Actually, there can also be part of the problem. So, but there's a huge, there's an increasing awareness of the process limitations, and people are working on it. So those technologies are being investigated. I'm not sure if anyone wants to actually speak up. So because we've had only chat messages, it would have been actually quite nice if you could also.
Let me make an urge. If any in the audience, if you want to say something or if you want to ask a question by yourself, please press the raise hand button at the bottom of your WebEx. And
So maybe to encourage people to do that, I will just say, okay, I would now ignore the chat function. So we only accept, if there are more questions, we will only accept questions that you ask yourself.
Okay.
So
Don't be shy.
Exactly. So we have a bit more of interaction here.
Yeah. Actually, I think raising the awareness of the public is the most important.
So especially because there are many.
Yeah, I want to add something. I think one thing is not only to clean the environment, but also to prevent actually that plastic enters the environment. So that should be one of the first steps. And I think everybody can try to pay a little bit attention and avoiding to release plastic into the environment. Especially like don't flush small plastic particles down the drain, put them into the trash.
Right.
Like these things.
If you're a smoker, don't throw your cigarettes away. I mean, those are obvious things, but I keep seeing people all around the world doing that. So it's, or yeah, in Taiwan, people like to throw their single-use, or yeah, please reduce your single-use consumption and try to use your own, bring your own cutlery, and there are easy things like straws. You can use metal straws. So there are all of those small things that add up in the end and make a difference.
And also for the facial cream, the scrub that we use, sometimes they use microplastic inside. So so it would be better if we use natural products for the particles inside, instead of using microplastic inside the facial cream with microplastic.
I think even that didn't encourage anyone at this point to raise the hand. We tried our best. So maybe the last call, last chance. So if you have questions, this is now a great opportunity to just ask, and there are no silly questions. So please just shoot out if you have. And so I'm just gonna wait for that last moment to pass and give you a chance.
Our audience are very shy.
I can feel that. Yes, they are. So in this case, the only thing that remains to say is if you have questions, you can reach out to us and we can answer them afterwards. But of course, it's always easier to answer it directly now.
Yeah, if you have any questions for the speakers and the chair, just give us a question via the Satu's email, the email that we sent you the WebEx link, and I'll forward it to the speaker and the chair.